So now in this video we're going to come back to an old diagram I put together. You got the flashlight right there. I'm going to cover that up. That's not terribly important to look at. The circuit depends on a flashlight hitting these lights. As you can see, the overhead light right there is not bright enough to turn this on. And so watch that red LED. There you can see, as I put the light on there, it took a bit of time, but now that LED is on. And when I remove the light, the LED is going to stay on for a little while. That's because we got a capacitor kind of storing the charge. I can discharge it, the capacitor, more quickly with my body right there. Now you can see it probably fading down. And also, we can just pluck it. So, didn't seem to want to discharge terribly quick there. If I put it back, it should still be partially charged. One interesting thing is that I find interesting is my body can easily turn it on and off right there. And it's actually not on terribly well. I'm seeing no current on the power supply. So it's probably less than 1 milliamp of current that we are getting right there. But in any case, there you can see it on. And we have the capacitor that I will put back. We will take a closer look at the circuit. So it looks like if I get the light right, I can get 9 milliamps. That's the most I can get. And when I remove the light, of course, current's going to go down over time right there. And it should go down quicker if I discharge it. Okay, maybe not. I'm going to pluck the capacitor. There it went down. There you can see, showed 1 milliamp briefly. But yeah, we're not getting much current with my body. So we could also just take the light with the capacitor off, and we should be able to get 9 milliamps if I get the light right. So I kind of moved it around. There we go. Now they're facing each other. And yeah, looks like maybe that's where we're settling right now. But any case, let's zoom in and look at the circuit more closely. So now zooming in on the circuit, we got the capacitor there, the top pin up there, the bottom pin down there. It is parallel to these LEDs. So we got this LED, the top pin coming to the jumper, which the capacitor also goes to, and then the bottom pin right there. So that's the anode, and top pin is the anode. Sorry, bottom pin is the cathode. Top pin is the longer lead if you have not cut them. And so again, same with this one. Longer lead on top, shorter lead on the bottom. Coming to the longer lead of this one, anode, down to the shorter lead cathode of that one. So the three of them in series and in parallel with the capacitor are coming to the base of the NPN bipolar junction transistor right here. So this is a 2N3904, and that's only about half of a microfarad, that capacitor. A smaller value capacitor will charge quicker, and also it will discharge quicker. So I probably would have used a lower value capacitor. But in case we're using 5 volts at the supply, 2N3904, that's the emitter down at the bottom where you see the arrow. And then we got the base in the middle, collector on top. If you're using a different NPN bipolar junction transistor, especially if it doesn't start with 2N, it could have a different pin layout. Just be aware of that. So yeah, we got the emitter at the bottom. So when this gets up to about 0.6 volts, it will start raising the voltage at the emitter. The emitter is going to be the base voltage minus about 0.6 volts. So about 0.6 volts less than you got there. Now it's coming to another NPN bipolar junction transistor. So that is down here. That's again the 2N3904. That jumper is going to the base middle pin. The top one's going to the collector, and then the emitter is coming to the LED. Same thing. Whatever voltage we got at the base, it's going to transfer, but we're going to lose about 0.6 volts. So about 0.6 volts less. So whatever the voltage is here, it's going to be about 1.5 lower, approximately there. And then we got our load. So doesn't matter which comes first. Current goes through series components the same. And so we got the anode up there, cathode there, resistor coming to the negative supply. The red LED is going to need about 2 volts. It's actually a little bit lower at lower currents before it like really starts glowing. But when it's lit up pretty well, it will have about 2 volts across it. So just to get the LED to light up significantly, we need about 2 volts plus 0.6, which is 1.8, and then plus about 0.6 more right there, for a total of about 3.2 volts when you add up all those drops right there before the LED really starts glowing right there. So main takeaway is these are emitter followers, the emitter, the voltage follows the base, but you lose about 0.6 and about 0.6 volts again. And then the load needs about 2 volts. So that's how this works. As we charge the capacitor, the voltage rises, and once it gets to about 3.2 volts, we have an LED that's lit like pretty well. It's going to rise some more. That's why it took time to discharge and dim the LED. So now, of course, these LEDs are not strong enough to create that power to light the LEDs. When it comes to transferring that voltage, pretty much all the power, just a speck of current is needed for that. Pretty much all the power that actually generates the voltage comes from the supply right there. And then same with this one right there. And so this is just kind of like an amplifier there, amplifying it even more. But the power comes from the actual power supply right there. That's something to remember. And so in any case, again, this is not a practical circuit. I just made this kind of for fun. Again, it's quicker to demonstrate it. If we move that, my finger can light it up a little bit right there. But more impressive is we get the lights on there. So we could use LEDs as a light sensor. This is not the best way to do so. And I might show a better way with an op amp in an upcoming video. But in any case, you could use it as a light sensor like that, especially if you got rid of the capacitor. But for whatever reason, I wanted the capacitor when I made the circuit a long time ago. This is an old diagram. So I stuck with what's on the schematic there. If I could think of a better way to demonstrate it, then I'll make another diagram. But for now, this is it. So hope you enjoy. Make sure you check out one of the other videos I'm posting on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.